All right, shall we continue? Uh, Again, because it's obvious now that I have a lot of time in my hands, I'm going to do a quick recap. And that is that we have talked about functions being pure, and we have talked about data being primitive, right? And that's what we have talked about so far. And one way of having fun that we have discussed is with memoization. Uh, and I talked about the fact that I use Redis for that to share the memos across processes so that other apps have got access to the same memos, to the same cache, right? I'm going to talk about the second and the last one, last idea that I have in terms of pure functions. And this is probably something you're already familiar with, is the concept of queues. Now, I wanted to start using queues, but when I looked at the sort of landscape around, right, in terms of, I don't know, AMQP or whatever those 4-letter words are, all 4-letter words should be banned. Seriously, I can't think of a good 4-letter word. Perspective. So it was clear to me that when an error comes into Errorception, it will have to go through some sort of a pipeline. And so, you know, already the functional model that I had been talking about of data passing through functions sort of seems to fit the pipeline model. But there was a reason for me to introduce queues into the picture as well, and I'll talk about that in a second. But before that, I want to talk about this particular implementation of queues that I created of a queuing server, which is actually a very fancy word to use because it's not a server at all. All it does is it uses Redis as a data structure store and is essentially just libraries that lets you write to the queue and read from the queue, and that's about it. There's this thing called queuemin, which I think was which in my opinion, is a very interesting name. But my sense of humor isn't the best, so whatever, take what you can from it. I'll give you an example of queuemin. Is that what you can do is you can say that enqueue. So the scenario is that, you know, some user has signed up and or going through the registration flow, and you want to send him an email saying welcome. You know, that typical email that everybody just deletes. You want to send him that email, right? And so so what you do is that rather than doing that in your flow, you can branch off and you can say that I want to put this into a queue and let that be handled elsewhere by somebody else to do. And so rather than calling, you know, the equivalent of a send mail function over there, you can just say that enqueue that into a mail queue, right? The mailer queue in this case. Just enqueue that into a mailer queue and be done with it. You can now respond saying that, hey, thanks, you know, thanks for registering and all that stuff. Meanwhile, what happens is that that data has gone and sat in Redis, and a different app, in this case mailer.js, imagine it being a completely different app, running in a different process space, you know, it's completely different from the previous one. What it does is it takes that data from the queue, the mail data, and it operates on it. Now, to understand how this plays into the idea that I've been talking about so far, you have to imagine that what I would have normally done is called send mail right over here and passed mail data as arguments to it, right? And that would send the email. But instead, what I have done now is that I have taken one function and I'm saying that this one function now behaves like an app for me. And I'm going to take this function, isolate it from the rest of the process, run that in a different process space. And that should be completely okay if the function is pure and if the arguments are trivially serializable, right? So I can take the function from within one process and run that in a different process space, and that is absolutely fine, and that should work, right? And so now what you can do is you can say that, all right, I've got a complex task to perform. What I'm going to do is I'm just going to queue that up for different apps to perform. Let those apps do that one thing. Remember, it's just a function call, really. In this case, send mail, right? It's just a function call. It's doing that function call, and then it's, you know, either its job is done or it's writing to some other queue, and so on it goes, right? And so you're building this sort of tendrils of processing that has to be done. But what's fascinating is that, the downside, of course, is that you have now got multiple processes to manage. But on the upside, what you get is a flexibility to deal with these things. And let me give you an example. So for whatever reason, let us say that my mail queue gets clogged up and there are just tons of emails now pending to be sent. What I can do is I can spawn another mailer process and now there are two mailer processes running, both reading from the same queue, right? But the two mailer processes are independent of each other. They probably don't even know about the existence of each other, and they don't need to because the functions are pure. And so the moment my mail queue gets clogged up, I can just start spawning more mailer instances, and that will help unclog the mail queue, right? And so that's just beautiful. I have seen that there is a scaling bottleneck in the way I'm handling emails. It's very trivial to scale that horizontally by saying that I can throw more processes at it and parallelly process all of those things rather than doing it within my own app, right? And so it's very simple for me to identify bottlenecks, first of all, which is a huge deal in itself. Just identifying bottlenecks is a big problem. And then trivially scaling it by saying, all right, I'll just have two functions doing exactly the same thing running parallelly. And that speeds up my processing significantly. And again, I can do this because it's pure and it is trivially serializable. Now, it is not absolutely necessary for it to be pure and trivially serializable. Obviously, the queuing is not an idea that was born in the functional world. It's in general an idea that is used in scaling heavily. But it certainly helps when it's trivially serializable and when it is pure, because you can now play with it without having to worry about what else is happening in that process space. Do I need to worry about things, state in that place and so on. Another case is that I have got the mailer app running. The registration flow is one such guy who sends emails. There are several other people who send emails as well. Like Twitter sends that annoying email every other day about, who are the, look at what your friends are doing types. And again, one of those emails that you always delete. But those emails can also land up in a queue. So there are guys whose job it is to decide what the email content should be. And there are guys whose job it is to send the email. Sending the email, that code remains the same, of course. So it's like the idea of code reuse. You have a send mail function and you call that whenever you've got the data ready. But except sending mail is happening in a different process. People are just publishing to the queue and there is a guy who's flushing away from the queue. So you have sort of got decentralized, you've broken up your app into several pieces now. And these pieces are talking to each other independent of each other. And this is very interesting. Now all of a sudden, there is no fundamental change in the way we are thinking about any of this though. We're still thinking about pure functions and trivial data. But it lets us start building all these things that let us take our app, break it up into pieces, scale that vertically or scale that horizontally, run multiple instances. And all of this just works trivially without you having to worry too much about, concurrency problems or what is the state of things or like, am I going to affect that and, by mistake or whatever. And that's really beautiful. The power of that is really amazing. And to be honest, this is, like I was just sitting down with a code review earlier with Shetty, and this is exactly what my code does, and I'll show you an example. This is how it works in Errorception, is that when an error comes in, it is encountered by the web server, and all the web server does, literally, is write it to a queue and say, thanks guys, thanks for the error. Job is done. Like literally, that's all that Errorception does at the outset. Meanwhile, it's sitting in some queue. Now, in the queue, I've got, I have to filter the error to make sure that it sort of matches certain criteria. Only then am I going to write it to the database. So it's like an if statement. Like if something is true, then continue. But rather than writing it as an if statement, I have that as a function which is going to return a true or false. And that function decides whether the item has to be written to the next queue or not, right? So that's like a filter. It takes out from the first queue and then decides whether it has to be written to the next queue or not. And so it's a filtering operation because some things might not be written, some things will be written according to certain rules. So it's literally an if statement that would otherwise have been in your code as an if statement. But here I've broken that out into a separate application and I run that application separately because that's a massive performance bottleneck for me because I've got tons of errors that I need to filter at the rate of 6,000 per second. I can't do it in one process. There's just not enough processing power for me to be able to do that. But it's trivial for me to use multiple cores of my box very easily. Go multi-core. Wow, that sounds awesome. You go multi-core without having to worry about all of these problems. That's amazing. Now, obviously, after filtering, there is deduplicating, which is sort of relevant only to me. And then there is, I have to write the raw logs to disk. And then there'll be third parties and stuff that I have to notify about errors. All of these things are happening by pumping data from queue to queue. And that's a really powerful idea because, so for example, well, here's another interesting aspect is that every once in a while, because my code is awesome, every once in a while it will crash. And so, that was a joke. My code is not awesome. It was the most horrible code you've seen. So it crashes. But imagine this. Now, let's say that there was some problem with the filtering code and that crashed. If it crashed, it's that one process that crashed. The rest of the app is working perfectly because the rest of the code does not have any inputs because the one in the middle has died. But at least the user does not know about this. The user still thinks that the app is working because he sends a request in and I acknowledge the request and I say, thanks, man, and it returns. And so the user thinks the app is working. Meanwhile, one of my app is down. I can come back later, aram se, and service that app to fix it or whatever, and it will take off from where it had left off, and it just continues, right? So it's like nothing has been lost. It's like everything just continues as normal. And so this gives you the flexibility to start servicing your apps. When I mean servicing, I mean bringing it down for some work and bringing it back up, maybe for an update or whatever. And you can do this trivially without having to worry about the rest of your app. So the rest of your app looks up. It's even processing the data. But there are pieces that you can pull out and you can say, all right, I want to shut this down, do an upgrade, bring this back up. And you can do that trivially with your setup if you're using this kind of a setup, right? Is that clear? Did that make sense? All right. So it sits in the queue, right? Because the intermediate data is essentially, what is the intermediate data? It's an argument that you are passing to the next function. So that's what's being sent to the queue anyway. So you can think of it over here. So here the mail data, for example, is the argument that is going to be passed to send mail. So that sits in the queue. That's the arguments, and the queues are in the arguments are in the queue. You can pop them out later, whenever you want, right? Right. Right. So, yeah, in my implementation, too bad, the mail. If you don't get the mail, it's too bad. In more professional queuing systems, what you would get is some sort of retry logic. So you would say that if this item failed, then pop it back into the queue and try again. But maybe delay it by 5 minutes. Let's wait for the system to recover or whatever. Give it 5 minutes and retry after 5 minutes. Or even better, you could have what is there's a term for that, where basically it retries in a degrading time scale. So it'll exponential decay, right? So it'll try after 2 minutes, after like 20 seconds, it didn't work. So let's reduce the decay slightly, and try it after 1 minute and so on. So whatever. So that's the process. I don't care about. One of the reasons I don't care about it is because I deal with errors, and there are just billions of them that I get. And so if I drop one or two here and there, nobody really notices. So it works for me. Don't tell anyone, please. But yeah, that's one of the reasons it works for me. But I guess it depends on how critical. Like for example, if you're using something like this for user analytics, if you drop one ping here and there, it's not the end of the world. It's okay. As long as your boss doesn't know, I guess life can move on. It's all cool. So that's how it works for me. Is it? Lots of things in Windows that don't work. Okay, and there is one more interesting sort of fallout of all of this. And we Node guys are notorious for bringing this up every time we talk about anything to do with Node. Is about the Unix philosophy, which is the idea that in Linux or in Unix tools, generally you find small apps that do small things, like grep or cat or whatever. These little small apps that do small things, and you string them together by using some interface. In this case, the interface is pipes, and you're passing arguments from one to the other and so on. So it sort of comes close to that philosophy where there is one app doing one thing. There is no shared global state. There is no such thing at all. The only thing the next app sees is what it gets from the pipe from the previous one. And so there is this elegance to it that has worked for Linux for sure, which is seeming to be translated over here by using the same model over here. Right? So you can compose your apps by using functions that pass data from one to the other much in the same way as a pipeline does. Except over here, rather than using a pipeline and store and passing it directly, I'm using it through Redis, but whatever, it's the same thing in a sense. And so philosophy thing is another interesting one. And finally, before I close, this is the last slide, Naresh. Before I close, this is what I have talked about so far, and literally this is what is this is how Errorception is built. Is that try to be pure, keep your data simple, cache, make caching very easy, so you can cache aggressively without having to worry too much, and break up your app into pieces, so you can scale each individual piece as you want, whenever you want, and allow for that message passing between apps to be very trivial, so you can build your apps the way you want, right? That's all I've got. Thank you. There's one more style, but that's about it. That's all I have. Thanks. If you have any questions, I'll give. When one of the processes dies, nobody finds out, which is a good thing. Especially if I'm at a bar or something, that's really important that nobody finds out. And the queue starts filling up. So what I can then do is come back. It sends me an email, so that's a good thing. And so I can come back, look at my email, realize that an app is down, and then go back and start the app. It's like nothing happened. Nobody will realize that it was down, because it'll take all the responses have gone out correctly. Whenever the request came in, the responses went out correctly. That's absolutely fine. And whatever was not processed is now remaining in queue. I can start processing that. So it's like I've not even lost data. The data is right there as well. So like an app is down, but I have not lost anything around it. That's just beautiful. So the HTTP server. So obviously, I have had to keep that to its bare minimal, so that there is no scope for things to go wrong. Because if that goes down, then I look bad, and you can't afford to look bad in today's world. So yeah. So the web server is written. It's written in raw Node code that is directly using the socket, so that I don't deal with the complexities of frameworks and all of that, just because who knows what code is running over there. So I'm talking raw socket, reading HTTP messages, parsing them myself, and storing them myself into the queue. And that's all it does. It does not have any frills in terms of cookie parsing or whatever else parsing. It does not do any of that. It's just taking the data, dumping that in the queue. That's it. Very simple. It's about 100 lines or so. It's very simple code. So I do get an email notification, but actually what happens, so in all reality, I have got a process watcher. What I do is, the process has died, respawn the process. It's an automated piece of code. So, but it does notify me that things are going wrong. Ideally, I mean, in most cases, I can ignore the email, because if it has reached the point now where if things crash, it's because I have done some wrong validation somewhere, and it's because of that things are crashing. The happy path of my code is absolutely fine. So in general, I ignore such cases these days, and the machine just keeps continuing to chug on. So it's absolutely fine. That's how it goes. Oh, so Naresh told me that I'm supposed to come here to talk about distributed computing, and I haven't even mentioned the word distributed. So I'll talk about that for a second. I'm not qualified to talk about distributed computing, because I have got one machine. That is what my server is. You'll never hear a guy talk about distributed computing when he's only got one machine to talk about. So for some reason, Naresh thought I was qualified. I have no idea. I'm not. But it's not very hard to imagine that I can go from here to a distributed setup very easily, because all my communication is happening over a socket with stores like Redis and MongoDB and so on. And they are all separate apps anyway. So I can just take it, and rather than running it on one machine now, I can run it on two separate machines, exactly the same code, no modifications whatsoever, and it's trivially distributed to multiple computers. The reason I have not done it is because I don't need to do it. It's not because I can't do it. The app already supports it. And the only thing I had to do was ensure that it is pure and it is trivially serializable, right? It's so simple. And with that, now suddenly I can spawn this across multiple machines, across the world, across the network, across whatever you want. And it's very trivial to write such applications. Very easy to do that. It's amazing. So I'm not an authority. I've never done distributed computing, but it looks to me like this might be helping with that. All signs point to it, at least. Right. 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 And so I wouldn't say that's wrong, obviously. When a request comes in, you deal with the request and you respond, and that's typically how you would write your programs. I do that as well. When a request comes in, I do something with the data and I respond, except that I don't process all of it immediately. I just write it to a queue. And this is because I can. I mean, there are tons of cases that you probably, if you sit down to think about it, you will come across them. There are tons of cases where you don't need to do the processing in your code at all. You can just take that and throw that off elsewhere and let somebody else do it. So if you can identify such things, I think queues are great candidates for such kind of things. And you just take them, throw them elsewhere, let somebody else process it. You don't care about it. Just continue with your execution. And so such scenarios, at least in my case, all of my critical code paths, which is all of the error logging, happens to be in that scenario where I can just respond and not have to actually process it really. And so my entire flow is based on queues, and that is how I scale. Does that help? Does that make sense? Any more questions? Yeah. Thanks. That was the intention. Thanks. Go on. Um, right. In my case, it involved a lot of beers, essentially, and yeah, it's basically sitting down with people and trying to look intelligent and trying to engage into conversation with them, where they start to divulge their deepest secrets about how they do software. That has generally worked with me. But no, really, this is because of I was influenced by the functional movement, this entire movement about functional programming. And again, like I told you, I wouldn't actually be pure functional ever because it's just ridiculous. But there are a lot of interesting ideas from there to grasp and to soak up, and to see if you can apply that into our everyday programming that we do, which is not necessarily pure functional, but at least see if you can imbibe those ideas and use them within your codes. That has worked for me over here. Again, like I said, this is not the only way to solve it. So I don't. If you ask me, are there other ways? I don't know if there are other ways. This has worked for me. It has worked for me beautifully, to the point that I might even say that I don't know why others are not thinking about this. But in all honesty, we all know that this is not the only way to solve it. There are several other ways as well. I'm just saying that this has worked for me, and it's definitely worth consideration. That's what I'm saying. Any other questions? Questions about beer are also fine. Not that I'm some connoisseur, but whatever. Time out. Uh-oh. You're putting me in a spot, dude. I have found that it is. It at least seems to work very well. Oh yeah, so I used to talk about that a lot in my previous talks, and then I realized that I come across as an alcoholic, which is true, but I don't want to say it too much. Because I always used to say that I got annoyed about the fact that my servers were crashing when I was sitting with friends and drinking beers. And so it's really bad to have to pull out the laptop and tether your phone and start SSHing into your server while your friends are having fun and the buzz of the booze is just setting in. That's not the best time to start debugging a server on production. So, I had to find a stack that would make this easier, and this is the approach that worked for me, basically. Hmm. Right. 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 So if no, I don't think it is, because if there is a case where you need to respond to the user immediately, it doesn't make sense to break it off from your flow currently. I mean, you could, it's sort of weird, but you could break it off and then come back somehow. But that's weird. I don't know if there's too much value to that. But if there is something that you can do out of band, then it makes sense to do it out of band. Hmm. Oh yeah, totally, totally. Right, 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 right. Sure. Yeah. Right. Huh. Right. 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 And there are cases where it is, like for example, on GitHub, when you make a commit and you push that commit to GitHub, there's a ton of stuff that GitHub does. They prepare a zip, they prepare a tarball, they will republish your markdown files. There is like just so much stuff that they do, which happens to be out of band. You don't need to do that when the commit is happening. It's ridiculous. So you can break that up and you can run that separately. So that's what I was saying, is that if you sit down to think about it, you'll be able to identify a lot of things that you can do out of band. And this fits that scenario very well. If it is in band, then probably this doesn't fit in very well. Right. 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 Correct. Correct. Yeah, when you tweet, Twitter just responds saying that, yeah, I've received the tweet. Thanks a lot. It might not actually be processed. That will happen somewhere else. That's how it goes. Huh. Correct. Right. 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 So yeah, the immediate response is that it was successful. It does not show you the latest state. The latest state you query for some other time, and that shows up. Yeah. Yeah, I didn't want to talk specific. I could definitely do. I would love to do that. It's JavaScript, man. I can talk about it all the time. But I didn't want to go there because I didn't want to make this centered around the language or around a particular database. It's far bigger than that in my head at least. That's about the idea of how to scale. But in particular, Node has got interesting challenges as well because it is asynchronous, which means that you can do multiple things in your process at the same time while you're waiting on other things like I/O and network I/O, disk I/O, whatever. While you're waiting for all of that to finish, you can meanwhile pick up other tasks and start processing them. And so at any given time, you're actually running tons of stuff in parallel, to sort of vaguely use that term. You're running tons of stuff in parallel within the same process. It is not actually in parallel, it's really sequential, so this is all a little tricky to explain. But yeah, it's sort of concurrent, it's sort of parallel, it's sort of not. But there is this weird model in which Node works. So there are, in essence, what is happening is that there's several things that it is working on at the same time. So when a request comes in, it's not like I have blocked the server while processing that request. There are other requests coming in as well, and they are being served from within the same process as well. And that's how Node works, and that's how it achieves its speed, is by not waiting on other guys. It's just doing thing after thing by itself as requests come in. I think that has confused you more than it has, but that's how Node works. Yeah, no, I don't think these are far more fundamental ideas than about Node. So I don't think that has had an influence. Though, of course, like for example, Cumin, the queue library that I showed you, lets you pop out multiple items from the queue at the same time. So you could just be saying that, hey, so the way it works is give me an item, and you get an item. Maybe you'll do some database query or whatever to find out more about how to do, about what to do with that item. So you're sitting down waiting for the database to respond or for the disk to respond. Meanwhile, it'll be like, hey, give me one more item because I'm just waiting. I'm doing nothing, right? So I might as well do something else until I wait for the database to come back. So you can pop out multiple things, and there are multiple things in flight inside your app, all of which have not completed. They're waiting on something else. So you're just, you're going to wait for those things to complete, and then continue where you had left off when you issued that. And so I have enabled that, but I don't think it's right to say that has influenced the design. That's probably not. But it's definitely, allowed for it within the code. So I can do multiple things within the same process. Cool. I'm just standing here because we have time. I could just call this off with that. Sure, sure. I don't know about content. I'm not the guy to. These are all very hardcore fundas, and I want to keep away from them because it's just too complicated. Uh, I'll tell you what I know. It'll probably confuse you more than you already are. Continuations are a way for you to. So these kind of terms are just very dicey to explain because people have got just so many opinions about what is the correct thing and what is the right. So it's a religious debate. But a continuation is a way by which you can say that. You go do that thing, and when you are done with it, let me know in some way. So the way you do that is I would have shown you an example, but the way you do that, actually I could show you an example. Well, it'll just get very, very complicated if I show you an example. But so continuations are used very heavily in Node, where so the way your code looks is that you say that so the registration flow, for example, you start the registration process and then you're like, oh, I need to make a database query to register the user. And when the database query is complete, here is the callback. Here's the function that you should call when that database query is complete, right? And so it looks like it is sort of within the same flow. It's one level nested because it's a function, but it looks like it's within the same flow. But your code has meanwhile gone out, done some I/O, and come back and so on, right? And so your code continues where the function was, and that's what a continuation is. This allows you, for example, to break off I/O from your process, and you can do a lot of funky stuff with that. I'm not going to go there. It's just too complicated. Are we good? Shall we wrap? Yeah. Thanks a lot. I hope this was useful to you. If you have any, if you have any questions at all, I'm just going to hang around for some more time. So feel free to come up.